You're welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 5 now from the October 2023 Edexcel International A-Level Statistics S1 exam. This question here is about normal distribution. It tells us about the weights X grams of a particular variety of fruit are normally distributed with, and what this means here is the weight X is such that it's normally distributed with a mean of 210 and a variance of 25 squared. So the mean is equal to 210 and the standard deviation is equal to 25. Okay, this is the variance, okay, not the standard deviation. You have to understand that. So the standard deviation is the square root of this, so it's 25. A fruit of this variety is selected at random. Show that the probability that the weight of this fruit is less than 240 grams is 0.8849. Okay, so we're going to have to understand about how to standardize the scores that we have, right? So we're going to standardize the weights of the fruit such that we transform the distribution such that the mean is 0 and the standard deviation is 1, which is what the table of values that we have for normal distribution are based upon. So to transform, basically, we're trying to find how many standard deviations above or below the mean, okay, this score is. And it's given by the Z. Z stands for the standardized score, all right, which is equal to the actual score, which we call X, minus the mean divided by the standard deviation. All right, so if you want to find the probability that X is less than 240, that will be the same as a probability that Z is less than, and we standardize the score. We take the score 240, we take away the mean, which is 210, and we divide by the standard deviation, which is 25. Okay, so that will give us the probability that Z is less than, we got 240 minus 2, that's 30 over 25, which is 6 over 5, which is 1.2. The probability that Z is less than 1.2. So we got to find the probability that Z is less than 1.2. So for this, we go to our table of values, okay? And we try to look for that probability. Now, if we try to picture what we're doing in terms of the normal distribution diagram, it'll be good. It's always a good idea to understand what's happening in terms of this diagram. So what we're trying to do here is we're trying to find the probability that Z is less than 1.2. Now 1.2, this is where Z is 0. Okay, this is the mean, where Z is 0. That's a standardized score for the mean. 1.2 is on the positive side. This is the negative Z side. This is the positive Z side. Positive Z side means you're above the mean. Negative Z side means you're below the mean. So 1.2 means we're above the mean, which makes sense because it's saying show that the probability of the fruit is less than 240 grams is 0.8449. That's an area which is greater than half the area. And you'll see in a minute what I mean by that. Okay, so we've got to find the value of Z such that we've got to find the probability that Z is less than this. So we've got to find the area to the left of this. Okay, to the left of this value of Z here. Okay, these are the Z value, which corresponds to the actual X value of 240. Okay, and this is the X value of 210, the mean. So we're going to find this area over here. This area over here can be found by looking at the table of values, and we go to Z equals 1.2, and we see what the area is associated with that. Now, in the table of values that we have, okay, which are shown over here, and these table of values that we have here, which are shown, let me just get the pen sorted out. Okay, we have basically this. If this is our normal distribution. Now the table that we're looking at down here is such that if we have Z equals 1.2, if we go to the Z value of 1.2, okay, these are the Z values. As you notice, they're all positive. Okay, they're all positive, and they start from 0 and they go further up. Okay, the area mentioned here is the area to the left of the Z value. So the area to the left of 0 is going to be half the area. Okay, because the mean is in the middle. When it's normal distribution, the in the middle, same as the median and the mode, they're all together. So it's halfway, so it means there's 0.5 of the distribution to the left and 0.5 of the distribution to the right of it. Half of it is on either side. Okay, we're looking for the area, which is to the left of 1.2. That's what we're looking for. So if we go to Z as 1.2, okay, we'll see over here. Okay, this is what we're looking for. The Z value of 1.2 is over here. That's what we're looking for, 1.2. So I'm going to take that and put this on this side of the, on this side. Okay, and I'm going to paste it here. So what we're looking for is this, okay, this here, which we can see is exactly what they asked us to find. Okay, so this area here is 0.8849. 0.8849. So that's what we had to show. Okay, so in this question, what they want to see is that you've standardized. They want to see the Z is less than 1.2. And then, it will be obvious that you use the table, or you could use a calculator. And I don't go through how to use a calculator ever, because everyone has different types of calculators, and there's different ways of dealing with it with different types of calculators, and it just ends up people getting confused. And you need to show this step. And some people just go and put everything in the calculator. They don't show any steps, and they write the answer down, which will not be sufficient, especially when it says show that. They want to see the standardization taking place, the 1.2 here. And so I think it's better just to use a table, to be honest, rather than use a calculator, unless you want to use it just to check, because of that reason. Okay, now for part B, it says the probability that the weight of this fruit is between 190 grams and 240 grams. We've got to find that probability. Well, we already have the probability of it being less than 190. Now we've got to find the probability of being less than 240. And now we've got to find the probability of being between 190 and 240. So what we can do is we can just take this diagram over here and just use this to illustrate what we're going to do. So what we have already found is this. Okay, this is where the probability of it being less than 240. So if we call this 240, all right, and in terms of Z, it's 1.2. Okay, so we got the probability of all of that below it, which was 0.8849. Now we've got to find the probability of it being between 190 and 240. Now 190 is not the same distance on that side. Okay, if it was like 180, then we could use symmetry here, but it's not 180, it's 190. So there's 20 on this side, 30 on that side, so it's not symmetrical. So I can't use symmetry like I was maybe thinking of in a minute when I first saw the question. So we got to now do something slightly different. We have here, this is where it's 190. Okay, what we need to find is the area between those two, the probability that it's between 190 and 240. Okay, so what we can do here is we can try to find what the value of Z is, okay, for this, and we can find the area on this side. Okay, we can try to find what the area is on this side, okay, because what we're looking for is the probability that that X is between 190 and 240. Okay, we can say that that's equal to the probability. You have 190 minus 210 over 25. Remember, 25 was the standard deviation. And the Z value here is going to be, we know that for 240 is 1.2. We already know that from the previous question. Okay, so 190 minus 210 is going to be minus 20 over 25. That's minus 20 over 25. I think that's minus 0.8. 20 over 25. Yeah, it's going to be minus 0.8. So this is the same as finding the probability that you're between minus 0.8 for Z and 1.2. Okay, now what we can do to find this is basically we can say that's the same as the probability that Z is less than 1.2, which we know, minus the probability that Z is less than 0.8, minus 0.8. Okay, Z is less than minus 0.8, which is, this is minus 0.8 in terms of Z, we need to find this area here. Okay, so I know this already. This is what we got the answer for here. We need to find what this area is. Now, what is the probability that z is less than negative 0.8? Well, we can't find that from the formula sheet, because on the formula sheet, what we'll have is z equals 0.8. Okay, if we go back to the formula sheet, here's a formula sheet over here. We don't have z equals minus 0.8, we have z equals 0.8. So I'm going to take that because we're going to use that actually. That's going to be something that we're going to use. So if I take that and we use that over here, okay, so now what we can say here is we need to get this value here. Now that is going to be the value that z is less than 0.8, which is going to be over here somewhere. Okay, 0.8 is going to be somewhere over here. That's going to be where z is equal to 0.8. Okay, so that was going to give us the area behind all of this. The area behind all of this. Okay, what we're looking for is the area behind this part here, which actually is the same as the area to the right of this. To the right of this part. Okay, this area is the same as that area. So we can say that this is equal to the probability that z is less than 1.2 minus 1 minus the probability that z is less than 0.8. Okay, because what we're looking for is the probability that z is greater than 0.8. Okay, because it's the same as the probability that z is less than minus 0.8. So less than 0.8. So if I do 1 minus this whole area here, 1 minus the probability that z is less than 0.8, this whole area here, 1 minus that, it's going to leave me with the area I'm looking for, which is this area. It's the same as that area. Okay, so we know that this is, as we found earlier, 0.8849 minus, and this area we know is going to be 1 minus, okay, the probability that z is less than 0.8, which is 0.7881. Write that neater. 0.7881, and that will give us our answer. So if we take this 0.8849 minus 1 minus 0.7881, that should give us our answer, which is 0.673. 0.673, and there's the answer that we need. That's the probability that x is between 190 and 240. 0.673. Okay, there's the answer to part B of this question. And we go on to part C. It says find the value of k such that the probability of x being between 210 minus k and 210 plus k is 0.95. So here we do have the situation of some sort of symmetry. So let me just use this. Okay, so here we know, and I'll make this bigger so we can write things a bit clearer. Here we know that the median is 210. That's the median. So everything's symmetrical about this median. And we know that we got a value which we don't know the value of, but you see it's 210 minus k. So this would be, if this was k, this is 210 minus k, and 210 plus k, so the same length on the other side. So the same length, okay, but on the other side. Okay, so you got symmetry here. Okay, so that's going to be also k long this way, but this is 210 plus k, right? So basically, I know that this area between those is 0.95. So this area between those two is equal to 0.95. Okay, this area here is 0.95. So what I can do here is I can try to find out what the whole of this area is. Okay, I can find out what the whole of this area is, okay, quite easily, because I know there's symmetry between these two. Okay, so for example, this area, just this section here, which I'll put maybe in a totally different color, this section here alone, I don't know if you can see the different color. I can't because I'm colorblind. Let me put it in blue. Let me say a black, a more gray black color. Okay, so this area here, the area here, okay, this is going to be 0.95 divided by 2 because this is symmetrical. Okay, divided by 2. All right, so you have 0.95 divided by 2, which gives us 0.475. 0.475. So this is the area of this section here. That's 0.475. And the area behind it, between 210 and negative infinity, all of this area is 0.5. The whole of this whole area here is 0.5. Okay, the whole thing. Okay, the whole area from the front to the back is going to be 0.5. Okay. So the whole of this area here is 0.5. Okay, so basically what we need to do is we need to find what this is. The value of x is here. Okay, so let's call this z first. Okay, so we can say the probability that the value of z is less than this z value here, z1, is going to be equal to 0.5 plus 0.475. I want to find what this z1 is. Okay, the z value. So we've got to find the probability that z is less than z1 is equal to 0.975. Now 0.975 is kind of like an exact type of value. It's like one of those values which we could maybe use a small table for. Now remember, the probability of in the smaller table, which is the one over here, that involves, this is the probability or the area, and this is the z value, but this is the area to the right of this z value. Okay, so when z is 0, which would be here, this would be the area to the right of it. When z is, for example, 0.8416, okay, this would be the area to the right of that, and so on. Okay, so what we're looking for here in our situation is we're looking for an area to the right of this value. Okay, so we're looking for this area here, which is going to be 1 minus 0.975, which gives you what? So you have 1 minus 0.975. That gives you 1 over 40, which is 0.025. 0.025. So we can say that the probability that z is greater than z1 is equal to 0.025. So we can use a small table. Now we're going to use a small table because we can, and it gives us more accurate value for z. So the z value for that is going to be equal to, if we go to our table, over here, we will see here the z value for 0.025 is over here. So this is what we're going to use. Okay. So let's take this here. So we can see from this that what we're looking for is this area value. And the z value that corresponds to it is 1.96. 1.9600. Okay, 1.96 is the z value we're looking for associated with that area. So now we want to find what x is. We know that x equals, or we know that z equals a standardized score, which is z is equal to x minus mu over sigma. Okay, so we know that mu is 210, and we know that sigma is 25. Okay, the standard deviation. So we can now use the standard score, which is 1.96, and that's equal to x, which we're trying to find. In fact, x is actually 210 plus r. 210 plus k, sorry, that is x, okay, minus the standard deviation, which is, sorry, minus the mean, which is 210, okay, over the standard deviation, which is 25. So we can say k is equal to 1.96 times 25. Okay, so we take 1.96, multiply it by 25, and you get 49. So k is equal to 49. Okay, so there's the answer to that question there. Right, so what we did was we used the fact that this is symmetrical. So I knew that this area is what's represented between these 2 points here, the area between them. I divide that area by 2 and I got this area over here. And then what I did is, in fact, what I could have done is I could have said this is 0.475. Straight away I could have said this is 0.025. I could have actually done this. I've gone through a bit of a extra bit of work, really. What would have been better for me to do at this stage was say that this area here is 1 minus 0.475, and that would have given me what we looked at, which was 0.025. I would have got there quicker, right? So then I could look at my small table, look for this area. That's a z value for which the area is this much to the right of it. So with the z value is 1.96, then I can unstandardize the score. So I know that this is the standardized score, 210 plus k. Okay, so that will give us the standardized score, and then we can multiply. I mean, when you rearrange this, that is a standardized score. And then what I did is I just, basically just simplify it. The 210 cancels with 210, and you're left with your k, which is equal to 49. So there's how we answer that question. Okay, so as I said, I went through a bit more work than I should have done, really. Okay, I spotted that at the end I could have just done, because I know that this is half of the whole area. Okay, so I know that half of 0.95 is 0.475, and then 0.5 minus this will give me this area over here, and that's the area that I'm looking for, the z value for which to the right of it is that, which I use this table for, and we can continue. So now we're done with part C, and we'll move on now. It says a wholesaler buys large numbers of this variety of fruit and classifies the lightest 15% as small. Find the maximum weight of a fruit that is classified as small. You must show you're working clearly. Okay, so that means basically if it's small, okay, the lightest 15% means, okay, that the maximum weight of a fruit that is from the lightest 15% is such that it's in a place where 15% of the fruit is less than its value. Okay, so we can say that this area here for let's call this the z value, which we don't know. This area here is going to be 0.15. Okay, so we can say the probability that z is less than this value. Let me call it something else. Let me call it w. Z is less than w is equal to 0.15. Okay, that's what we can say here. All right, so we want to find what the value of z is for that to be this to be true. Now 0.15 again looks like one of those values which we might be able to see in the small table. And if we just verify that by going back to the small table, 0.15 is. So we're going to use this, but we'll have to use it in a slightly different way, as I'll show you in a minute, because as we know, this refers to the area to the right of a z value, and we see our z value has to be negative. Okay, so I know that by symmetry, I can say that, let me just get this sorted out. There's a value over here, okay, which is the opposite sign of this value. So I'll put a minus here. It's opposite sign of this value, such that the area to the right of this is 0.15. So we can say our minus is our minus z value. I'll call it z because it is the actual z value. So I'll call this the z value of finding, and that's the opposite sign. Okay, so minus z is going to be here. Remember, this is the area, and this is the z value. So it's going to be it's going to be negative or it's going to be minus z is going to be 1.0364. So our value of z is going to be negative 1.0364. Okay, so this is negative 1.0364. That's the one we are interested in. We had to find this because the tables only give us positive values of z. So whatever value of z we found here, we have to change its sign. Okay, so that is a standardized score now. Okay, that is a standardized score for the maximum weight. So we can now find the maximum weight by using our formula. Z equals x minus mu over the standard deviation. So we know z now is minus 1.0364. That's equal to x, which we have to find, minus mu, which is 210 over 25. So we can say x is going to be equal to, it's going to be 210 minus 25 times 1.0364, and that will give us our answer. So you have 210 minus 25 times 1.0364. Okay, and that will give us our answer of 184.09. You can leave it like that. You can write it as 184. Both of those are fine. Okay, so there's the answer to part D. So this is quite a long question on normal distribution. Actually, they don't normally come this long, but it's pretty doable. So that is the weight, okay, of that fruit. Okay, which is the largest of the maximum of the ones classified as small. It's at this point here where 15% of the fruit is smaller than it. Okay, so there's part D. So whenever you get something on the negative side, you have to use symmetry. And whenever you're able to use the small table, you must use it, otherwise you will definitely lose marks. Okay, so you can't use the big table for this. You have to use the small table because you have an area which is compatible with that, something that you these kind of exact values for areas. Now for number or part E, it says the weights y grams of a second variety of this fruit are normally distributed with a mean of mu and a standard deviation of sigma, which we don't know. Given that 5% of these fruit weigh less than 152 grams and 40% weigh more than 180 grams, calculate the mean and standard deviation of the weights of this variety of fruit. Now this is a very standard type of question you'll find in lots of past papers and in the books and stuff, and I've got some things here to help us. So basically, we're going to form two separate sets of equations, okay, or two equations, and from the information given, and we're going to use those equations and solve them simultaneously, basically. So the information we're given is about two different situations, and I'm going to use the small table, so I'll bring this up here as well, so everything's in place. Okay, so now, let's look at the first situation. They've told us about the 5% of these fruits weigh less than 152 grams. So it says 5% weigh less than 152. So 152 must be over here. It must be somewhere on the left side of the mean, because the area to the left of it is only 5%. That's 0.05. Okay, and this is 152 grams. Okay, so we know that 5% weigh less than 152 grams. So what we need to find now is the Z value for this. Okay, and we're also told in the other situation that 40% weigh more than 180 grams. So 40% is less than a half, but it says more than 180 grams. So that means greater than 180 gram is going to be only 40% of the amount. So 40% must be, this 180 must be somewhere over here, such that the area to the right of it is 40%. Because 40% weigh more than 180 grams. Okay, so that's going to be 0.4 area here that we're looking for. Now for this, we have 0.05 as an area in our table. 0.05 is right here. We have that as an area in our table. Okay, so I know that this value of Z here, okay, is not what we're looking for, is not what we have in the table, because the value in the table is to the right. Okay, that area is to the right. So that Z value is actually 1.6449, such that the area to the right of it is 0.05. But because of symmetry, this Z value must be negative 1.6449. Okay, so this is what we're looking for here. And in this case here, we are looking for an area. This is to the right. 0.4 is in our table. So the other part that we're looking for is this part over here. And that Z value is the correct Z value with the correct sign. So the Z value for this is 0.2533. So now I have worked out what the Z values are for those particular situations. I can now go ahead and answer the question without any issue. So let me just go ahead and answer the question now. So now we can use the fact that the standardized score is X minus mu over sigma. We don't know mu and sigma, but we know Z and X for both of these situations, and that's why we can solve the problem. So here the Z value is 152. That's equal to, the Z value is minus 1.6449, negative 1.6449, and that's equal to the actual value 152 minus the mean over the standard deviation, which these two are unknown. And here we have 0.2533 is equal to 180, the actual score, minus the mean over the standard deviation. And the mean and standard deviation are the same in both cases. So now we can have a pair of simultaneous equations, 1.6449. I'll write this out in the middle so it's clearer. So if I take these two equations and have minus 1.6449 times the standard deviation is equal to 152 minus the mean. If I take this one, I'll have 0.2533. Okay, sigma equals 180 minus mu. So I have equation 1 and I have equation 2. If I subtract them, if I do equation 2 minus equation 1, okay, I'll end up with these two having to be added together because I have this minus that. So I have 0.2533 plus 1.6449. That gives us 1.8982 sigma. So I'm just subtracting them. So 1.8982, is that what we got? Yep, time sigma is equal to, if I subtracting this way, that's going to give me 28, and these will be eliminated. Okay, so this is, just put that bit in there. I didn't write the sigma very well there, did I? So therefore, I can say that sigma is equal to 28 divided by 1.8982. So we can say sigma is therefore equal to divided by 28 divided by my answer, which gives me 14.7508, 14.7508, So we should round in the end to 3SF, so 14.8, that's sigma. And we can say mu, we can find from one of these. I can say that, let's use this one, mu is going to be 180 minus 0.2533 times sigma, which is 14.7508. Okay, so mu is going to be, if we just put this in the calculator now, so 180 minus, we have 0.2533 times the last answer. Times the answer, which was this. And that will give us our answer, which is 176.2636. 176.2636. So we can say that mu is equal to 176 to 3SF. Okay, and there goes our answer. And that's it. Okay, and yep, so we have finished the whole of this question. So this last part is quite a standard type of question that you'll see where you don't know the mean or the standard deviation, but they give you two situations on that, you know, two different bits of information about the problem, and then you have to form a pair of simultaneous equations. Your only unknowns will be sigma and mu, and you can find them. Okay, so there's the answer to this question. So this was 176, the mean. Okay, and this is the standard deviation, in case you want to clarify. Okay. So that completes question number 5 from the October 2023 S1 paper. Other questions from the paper can be found in the playlist that will appear in this section over here. Other questions from the topic of normal distribution from the playlist over here. You can subscribe to the channel by clicking on this link over here. And over here, you'll find a video which will help you to find what you're looking for from my channel. Thank you for watching and see you soon.